Welcome to the next lecture on capturing high quality aerial images. In drone surveying, the quality of the final maps and 3D models depends heavily on the quality of the images captured during the flight. Even the best photogrammetry software cannot produce accurate results if the images are blurry, poorly exposed, or inconsistent. That's why capturing clear, sharp, and well aligned aerial images is a critical skill for every drone surveyor. Let's explore the key factors that help ensure high quality aerial image capture. First, use the right camera settings. Before starting the survey mission, it's important to configure the camera settings properly. One important setting is shutter speed. Because the drone is constantly moving during a survey mission, the camera needs a fast shutter speed to prevent motion blur. A faster shutter speed helps freeze the scene and capture sharper images. Another setting to consider is ISO, which controls the camera's sensitivity to light. Lower ISO values usually produce cleaner images with less noise. Many surveyors also prefer capturing images in high resolution formats, ensuring maximum detail for photogrammetry processing. Second, maintain proper flight stability. Stable flight is essential for capturing clear images. Strong winds or sudden drone movements can cause the camera to tilt or vibrate, leading to distorted or blurred photos. Survey flights should ideally be conducted in calm weather conditions with low wind speeds. Modern drones include stabilization systems and gimbals that help keep the camera level, but stable flying conditions still play a major role in image quality. Third, ensure consistent image overlap. Photogrammetry relies on overlapping images to reconstruct the terrain accurately. During a mapping mission, the drone captures images with planned front and side overlap. Consistent overlap ensures that every part of the survey area appears in multiple images. If the overlap is too low, the software may struggle to align the images correctly, which can create gaps or distortion in the final map. Fourth, fly at a correct altitude. The flight altitude directly affects the level of detail in the images. Flying too high may reduce image resolution and make small features difficult to detect. Flying too low may capture more detail but require many additional images. Surveyors typically select an altitude that produces the desired ground sampling distance while maintaining efficient coverage of the survey area. Fifth, consider lighting conditions. Lighting plays an important role in aerial photography. The best time for drone surveys is often during consistent daylight conditions, when shadows are minimal and the lighting is evenly distributed across the landscape. Very strong shadows, glare, or low light conditions can make image processing more difficult. Sixth, keep the camera facing straight down. For most mapping missions, the camera should be positioned vertically downward, also known as the nadir position. This orientation ensures that images align properly during photogrammetry processing and produce accurate maps and terrain models. Capturing high quality aerial images requires attention to camera settings, flight conditions, and mission planning. By following these practices, drone surveyors can collect imagery that leads to accurate orthomosaic maps, reliable measurements, and detailed 3D models. In the next lecture, we will explore some of the most common mistakes made during drone survey missions and how you can avoid them. See you in the next lecture.